So, our next lesson class is about the design of square footing. So, you have to read yung chapter 9. I think it's chapter 9 kung saan yung introduction of footing. Yes, it is on chapter 9 class. So, you have to read chapter 9. It will be included in your recitation. So, lahat ng about sa chapter 9. Okay, ang chapter 9 at chapter 10. So, itong dinidiscuss ko ay ganyan na to. Combination ng chapter 9 and chapter 10. Ito na yung end natin. So, this will be our last topic for our prelim. So, design of square footing. Example class, a 400 mm square tied column supports a dead load of 900 kN and a live load of 700 kN. The column is reinforced with 8 25 mm diameter RSB. A square footing is designed to support this load with its base at 1.5 meter below the ground surface. The allowable soil pressure is 240 kilopascal. Assume that the soil weighs 15.8 kilonewton per meter cube and the concrete to be 23.5 kilonewton per meter cube. Use F prime seat as 21 megapascal and Fy as 415 megapascal. Design the footing. So, first, we are going to imagine class. Before we design, kunin natin yung description ng ating problem. So, palitan natin ng ink. Gawa tayo ng kulay red. Okay. Kulay yellow na. Or kulay red. Okay, so ito-drawing natin siya. Square footing siya. Meron siyang dimension na B. Tapos, meron siyang load na ano ang load niya? 900. And meron siyang live load na 700. Okay? Tapos, ang depth niya daw mula sa ground surface. Ang depth niya daw mula sa ground surface ay 1.5 meters. Ano pang sinabi? Okay, so yun lang. So, gagawin natin design the footing. So, i-summarize ko class ko ano yung gagamitin natin on design of footing. Anong gagamitin nating ink? Gusto ko ng orangey. Okay, so how are we going to solve this one class, design of footing? So, una nating i-design class, if you read chapter 9 class, kagaya ng ginawa natin sa bearing capacity, i-check muna natin yung area ng ating footing. So, importante yun class. So, ang makuha muna natin is the area of the footing and then sunod na yung thickness niya. And then after ng thickness niya, tsaka na yung kanyang reinforcement. Okay, so ang first natin gagawin is to get the area. Okay, so first. So, solution natin. Okay, so ang first step natin dyan, class, ay mag-a-assume tayo. So, first step is to assume. I-assume natin yung thickness ng ating footing. So, yun yung step dito, class. So, we are going to assume the thickness of our footing. Ang tawag dito ay T. Ano pala yung gamma natin? Meron tayong gamma, di ba? Ang gamma natin dito ay 15.8 kilonewton per meter cube sa ating soil. So, assume tayo ng T. Assume T as, so, ang gagawin natin, mag-assume tayo ng T, kukunin natin yung area, and then, i-check natin to ng shearing. Tapos, kapag tama, ibig sabihin tama yung assumption natin. Okay? So, first step natin is to assume T. Pero, para mas maganda yung pag-solve, i-by parts ko na lang to. Yun natin, A, size of the footing. Okay? Then, first step, assume thickness. Okay, so when we assume thickness, class, dapat taas-taas yung thickness na i-assume natin sa ating concrete para makatipid tayo sa bakal. Kasi kapag makapal yung concrete natin for footing, class, mahirap siyang i-shear. And then, pagdating ng reinforcement natin, pagdating sa flexure, konti na lang yung kailangan nating bakal kasi nga mahirap siyang i-bend kasi nga makapal. So, ang thickness natin, assume tayo ng gagawin nating X-Sag, gagawin nating 600. Gagawin nating 600. And the effective depth, thickness yan ng concrete. So, ang effective depth niya ay 600 minus ang concrete cover? Ang minimum concrete cover ng footing natin, class, sa NSCP ay 75 mm. So, pwede nating gawing 75 or pwede nating taasan, gawin na lang nating 80. Sige. Gagawin nating 520 mm yung ating effective depth. So, effective depth ang tawag dyan. So, next is we are going to get the effective soil pressure. So, ang effective soil pressure, effective soil pressure, class, Q, that is your Q allowable minus yung Q natin na effective stress. So, ang Q allowable natin is, yung sinabi? Given 240 minus, yung Q natin? Mas magandang mag-solve ng ang ink natin ay blue. So, niya natin. Parang blue ball pen. Oo, mas cute siya. Q, 240 minus gamma Q allowable. Q allowable is equal to 240 minus summation of gamma D. Ano yung summation of gamma D? Effective stress yan. Mali ako. This is Q effective. 240 yung Q allowable. Q effective is equal to Q allowable. That is 240 minus summation of gamma D. Okay, so isulat ko na nga lang to. This is Q allowable. Okay? So, Q allowable 240 minus summation of gamma D. Gamma, 15.8. Ano yung thickness ng soil? So, since 1.5 mula sa ground surface, that is 1.5 minus thickness. Assume natin 0.6 minus or i-plus natin. Diba? Plus concrete, yun? 23.5 times thickness of concrete. Okay, so solve natin yan. 1.5 minus 0.6 times 15. Okay, may calculator. Yung calculator, gawin nyo to. 1.5 minus 0.6 plus 23.5 times 0.6. 28 to 40 minus 28. 211. So, Q effective is 211.68 kPa. Para saan ito? Kasi, ang gagamitin natin, class, so to get our area required, Q effective is equal to unfactored load over area required. So, yan yun. So, ano yung effective natin? 211.68 unfactored load. Ano yung unfactored load? We have 900 plus 700 over area required. Anong area required? B. Diba? Square siya, B squared. So, we can get B as our effective width. Ano to? 900 plus 700 over 211.68. effective required width is 7.56. So use, taasan natin 7.6 meter, use B. So, kung ang required niya ay 7.56, dapat mas mataas dyan yung gagamitin mo. Hindi pwedeng ang required niya is 7.56, tapos ang gagamitin mong B is 7. So, it should be greater than 7.56. Pwede mong gawing 8, pwede namang 7.6 na lang. Pasado naman siya, di ba? Pero i-check pa natin. And then, ano tong step na to? Step 1 pa lang. Okay, so step 2, QU. Ultimate na tayo. So, QU is equal to factored load over area. Okay? So, 1.2D plus 1.6L. So, shortcut na 1.2D 900 plus 1.6700 over yung area na nagagamitin mo, 7.6 squared. Hindi yung area required. So, ang QU natin ay, dito tayo taas. QU is equal to 1.2 plus 1.6. Ba't ganun? Ba't parang mali ako? 1.2. Bakit ang B natin ay 7.6? Ang laki naman yan. May mali ako. Saan ako nagkamali, class? Ayoko nang i-record to ulit. 900, 700 to 11.68. Square root of answer. Ba't ganun? Ba't ang laki? Okay. Square root of 7. Di pa pala kasi tapos ito. So, this is what? This is 2.75 meters. Pwedeng mas mataas ng 2.75. Pwedeng mag-eksaktong 2.75 na kasi saktong 2.75 naman na to. O kung sigurista ka, pwede namang sige 2.8 na lang. Diba? Para feel natin na mas mataas siya ng 2.75. Pero pwede ng 2.75 yan kasi 2.749 naman siya. 2.8 square. Okay, so compute tayo. Okay, so 2.8 square. It is 280.61 kPa. Ngayon, gagawin natin, third step is check on one-way shear. You have to read chapter 9 para maintindihan nyo atong one-way shear na to. So I'm going to explain, class, that sa ating footing, we have one-way shear and two-way shear.